This is a very strange question, but it will still give us a chance to tinker with linear equations. So we're going to have a string that's 10 inches long. And we are going to cut that string somewhere in between the two ends, say like right there. And then the two pieces of string that result are each going to form a square. And we want to know, where should we place the cut so that when we calculate the area of this square and the area of this square, the difference between those two areas is 10 square inches? Well, here we are looking for the answer to where should the string be cut. So where is this location? That location is unknown. And when you have an unknown, perhaps you should be able to solve for that unknown with a variable. And so I'm going to name as x the position, bigger than 0 but less than 10, where we're going to go snip on this string. Now with that cut in place, this piece of string comes down to form this square, so that string just lays out in this shape. Since it's going to be a square, each of those edges has to be a length x over 4, so that the whole thing has a total length of x. Over here on this square, the length of string that's left to use is 10 minus x, and each of those sides has to be a fourth of that total because we're making a square. And we want to know, how are we going to make this cut so that the areas of the two squares have a difference of 10. So pardon me while I scoot the paper here. The area of this square, let's call it A1, that is x over 4 squared. The area of this square, let's call it A2, is 10 minus x over 4. Come on, there's an x. That really is an x, trust me. 10 minus x over 4 squared. And we want A2 minus A1 to be equal to 10. Now, you might be thinking, wait a minute, you promised me linear equations, and look what you're doing. You're giving me x squareds. How dare you? Well, peek ahead. As soon as we take this and multiply this out, and then make the difference, the x squared terms are going to vanish. So A2, when I carry this out, the numerator of 10 minus x is 100 minus 20x minus x squared, all of that over 16. And then minus the first area, x squared over 16. That wants to be 10. Now, this term is going to separate across the minus signs, right? Oop, that should be a plus, shouldn't it? So it'll be 100 over 16 minus 20x over 16 plus x squared over 16. That x squared over 16 is going to cancel that one. So I'm not going to write that intermediate step, but those two terms are going to take care of themselves. 100 over 16 is 25 over 4. 20 over 16 is 5 halves. Is 5 fourths, and that needs to be 10. I'm going to multiply both sides of this by 4. I could combine these terms first, but there's no need to. So multiplying both sides of that equation by 4 will give me 25 minus 5x equals 40. That will give me negative 5x equals 15, or x equals negative 3. Now that's kind of awkward for two reasons. One, I should have set this up a little bit better so it wouldn't come out to be negative 3. But since it has happened to come out to be negative 3, let's just interpret that in terms of the question, because the length of this cut cannot be -3. I hope you agree with that. But all I said in the problem was that I need the difference in the areas of these two squares to be 10 inches. So I happen to write the distance as A2 minus A1. I could have written it as A1 minus A2. And if I'd done that, all these calculations would have been pretty much exactly the same, except, terms in different orders, and this would have turned out to be x equals plus 3. So I'm going to adapt, and I will say cut at x equals 3 inches.